Picture this. The year is 2050, and somewhere on the dusty red surface of Mars, a city lights up against the darkness of space. Not a small research outpost, not a temporary base. A real city, with thousands of people living, working, and building the future of humanity on an alien world. This isn't science fiction anymore. SpaceX is betting everything on making this vision real. But transforming Mars from a barren wasteland into humanity's second home is going to take more than just rockets and dreams. It's going to require solving problems we've never faced before, building infrastructure that doesn't exist, and creating an entirely new branch of human civilization from absolute scratch. So how does SpaceX actually plan to pull this off? Let's break down the engineering roadmap for building a city on another planet. The first thing you need to understand is what makes a Mars city fundamentally different from any other human settlement we've ever built. And it all comes down to one word: independence. Think about a lunar base for comparison. If you're living on the moon, Earth is basically right next door. About 24 hours of travel time away. Need medical supplies? Call Earth. Running low on spare parts? Earth can send them. Want to come home for the holidays? Book a flight. Mars destroys that safety net completely. We're talking about 8 months of travel time each way under current propulsion technology. Even if we crack nuclear thermal rockets and cut that down to the absolute minimum, you're still looking at 45 days minimum transit time. That distance changes everything. It means the people on Mars can't depend on Earth for survival. Every kilogram of food, every litre of water, every breath of oxygen has to either come with them or be produced locally. There's no emergency resupply mission. No cavalry coming over the hill if something goes wrong. And here's the really sobering part. SpaceX's plan assumes that one day the ships from Earth will simply stop coming. Maybe there's a war, maybe there's an economic collapse, maybe Earth just loses interest. Whatever the reason, the Martian colony has to be designed to survive complete isolation. That means we need roughly 1 million people living on Mars, with fully functional industry, agriculture and infrastructure, before we can truly call ourselves a multiplanetary species. 1 million people represents the minimum viable population for maintaining technological civilization without external support. So how do we get from 0 to 1 million? It starts with an army of robots. Before a single human being sets foot on Mars, the planet will already be inhabited. Not by astronauts, but by dozens, maybe hundreds, of autonomous machines. And the first wave of those machines is going to look surprisingly familiar. Optimus, Tesla's humanoid robot. It's probably not a coincidence that Elon Musk's other company is developing the exact technology SpaceX needs for Mars colonization. Optimus is designed to perform any task a human can do, which makes it perfect for preparing Mars for human arrival. Because here's the brutal truth about Mars. It's the most hostile environment humanity has ever attempted to colonize. The surface temperature averages -63 degrees Celsius. That's colder than Antarctica in winter. The atmosphere is so thin that exposed liquid water instantly evaporates. There's no magnetic field, which means deadly solar radiation bombards the surface constantly. Put a human outside without a pressure suit on Mars, and you'd simultaneously freeze, boil, and suffocate. Your blood would literally start to vaporize. It's about as close to hell as you can get without leaving the solar system. This is why the robots go first. We can't send humans into that environment unprepared. We need infrastructure in place before the first colonists arrive. And building that infrastructure is going to be Optimus's job. The timeline starts as early as 2026. 5 Starship landers, each carrying 10 tons of robotic equipment and supplies, launched during the first Mars transfer window. Now, SpaceX is being realistic about this first mission. The primary goal isn't to build anything. It's just to land without crashing. Anyone who's followed SpaceX knows their development philosophy. Rapid iteration. Learn by doing. And yes, things blow up along the way. So they're sending 5 ships because they expect some of them to fail. If even one lands successfully and deploys its robots, that's a win. Those first robots won't have much to do except survive and gather data. But 2 years later, during the next transfer window, the real work begins. 20 Starships arrive, each carrying 75 tons of cargo. Now we're talking about serious equipment, mining rigs, processing plants, power generation systems, construction materials, everything needed to start building the basic infrastructure of survival. And all of this is happening in a very specific location. SpaceX has identified the Arcadia Planitia region as the prime settlement zone. It's positioned just northeast of Olympus Mons, that massive volcano that dwarfs anything on Earth. Why Arcadia? 2 reasons. First, it's relatively flat terrain, which makes landing easier and construction more practical. Second, and more importantly, orbital surveys suggest there are massive deposits of water ice beneath the surface. Water is the key to everything on Mars. It's not just about drinking, though obviously humans need that. Water can be split into oxygen for breathing and hydrogen for rocket fuel. It can be used as radiation shielding. It's the single most valuable resource on the planet. So the robot's first major project is building a water extraction and processing facility. They'll dig down into the Martian regolith, extract ice, melt it, purify it, and feed it into systems that break it down into its component elements. The hydrogen gets routed to the fuel production facility. Because here's a problem most people don't think about. Getting to Mars requires almost all of your fuel. There's nothing left for the return journey. If you want to come home, you need to manufacture fuel on Mars. SpaceX chose methane as Starship's propellant specifically because it can be made on Mars. Methane is just carbon and hydrogen. We get hydrogen from water. We get carbon from the atmosphere, which is 95% carbon dioxide. So robots will construct a Sabatier reactor that pulls CO2 from the thin Martian air, combines it with hydrogen from water, and produces methane fuel plus oxygen as a byproduct. It's elegant, it's efficient, and it makes the return trip possible. All of this infrastructure requires mining operations, not just for water ice, but for raw materials. The Boring Company's tunneling technology, scaled down for Martian use, will dig into the subsurface. And all that excavated rock and soil doesn't go to waste. It gets processed into a crude form of asphalt for landing pads and roads. By 2030, after 2 years of robotic construction, the infrastructure is ready. And that's when the first humans arrive. 100 Starships, each carrying 150 tons of cargo and crew. This is the real deal. The actual colonization fleet. The first priority when humans land is power generation. Up until now, the robots have been running on solar panels and small battery systems. But human life support requires massive amounts of continuous energy. Life support systems need to run 24/7. Oxygen generation, water recycling, temperature control, pressure maintenance. All of it demands reliable, abundant power. Fortunately, Mars has one big advantage. The day length is almost identical to Earth's. 24 hours and 37 minutes. So solar power works on a familiar cycle. Panels charge during the day, batteries carry the load at night. And again, not coincidentally, Tesla manufactures industrial battery systems called megapacks. Each one can power a small town for hours. A few megapacks keep a Mars colony running through the Martian night without any problem. But power is just one piece. People need shelter. And this is where Mars colony architecture gets really interesting. Sure, Starship itself provides immediate housing. Each lander is essentially a ready-made habitat. Pressurized, radiation shielded, equipped with life support. Colonists can live in them, while permanent structures are built. But Starship makes for terrible long-term housing. It's tall, narrow, and inefficient. You need an elevator just to move between floors, so permanent habitats become the next construction priority. When most people imagine Mars colonies, they picture giant glass domes, and eventually maybe we'll build those. But for the first settlements, glass domes are completely impractical. Consider the engineering challenge. The largest dome-like structure on Earth is probably the Nature Conservatory at Singapore's airport. It encloses about 135,000 square metres and weighs 3,500 tonnes. That would require 350 Starship flights just to transport the materials, plus all the heavy machinery to assemble it. We need to work with what Mars gives us. And one of the things Mars has in abundance is water ice. So researchers at NASA Langley have proposed ice domes. The concept is brilliant in its simplicity. Start with an inflatable structure as the core framework. Build a mould around it, then have robots fill the mould with water ice extracted from the Martian subsurface. The ice freezes solid, forming a thick protective shell. Ice is an incredible insulator. That's why igloos work in the Arctic. But on Mars, ice serves double duty. It blocks radiation. Water is one of the most effective radiation shields we know. Thick enough ice walls would protect colonists from the constant solar bombardment that makes the surface so deadly. Plus, the ice would be translucent. Not transparent like glass, but translucent enough to let diffused sunlight through. That natural lighting would be crucial for mental health and maintaining normal circadian rhythms. Ice domes work great for habitation, but what about laboratories, factories, greenhouses? For those, we need more versatile construction materials. And this is where things get weird, because the best building material on Mars might be human waste. The concept is called biocrete, or astrocrete. Researchers at the University of Manchester discovered that human urea, the waste product filtered out during urination, can be mixed with Martian soil to create a form of concrete stronger than what we use on Earth. It sounds insane, but it's actually based on ancient technology. Medieval stonemasons mixed animal blood into their mortar to strengthen it. Same principle, just applied to space construction. So the waste products from human biology become construction materials. Urea gets mixed with processed regolith to form biocrete shells around inflatable habitat cores. Nothing gets wasted. Every byproduct of human metabolism gets recycled into something useful. Which brings us to the hardest challenge of all: food. You can bring water purification systems from Earth, you can manufacture fuel on site, you can build shelters from local materials, but feeding 1 million people, that requires agriculture. Real productive farming on a planet where the soil is literally poisonous. Martian regolith is contaminated with perchlorates. These are chlorine-based compounds that prevent biological growth. The same stuff we use to kill bacteria in swimming pools. Plant anything in raw Martian soil, and the perchlorates will kill it. So we have two options. Either we transport all agricultural soil from Earth, which would require thousands of Starship flights just for dirt, or we build yet another industrial facility to process Martian soil, extract the perchlorates, and add nutrients to make it viable for farming. Processing is the only realistic option, which means building soil remediation plants, nutrient synthesis facilities, and vast underground greenhouses where crops can grow protected from radiation and temperature extremes. And once again, human waste becomes a critical resource. Solid waste gets composted and used as fertilizer. The nitrogen, phosphorus, and organic compounds that our bodies excrete become the foundation of Martian agriculture. It's not glamorous. Nobody dreams about becoming a Mars colonist so they can work in waste processing facilities. But this is what self-sufficiency actually looks like. Every resource gets used. Every waste stream becomes an input for something else. The entire colony functions as one giant closed-loop system. If SpaceX can nail all of these systems, power, water, oxygen, shelter, and food, produced entirely from Martian resources, then humanity takes its first real step toward becoming multiplanetary. Because the ultimate test isn't whether we can survive on Mars with help from Earth. It's whether we can survive when Earth stops helping, when the supply ships stop coming, when we're truly on our own. That's the vision. Not a research station, not a temporary outpost, a real city, a permanent human settlement that can sustain itself, grow, and eventually become completely independent of Earth. The timeline is aggressive. First robots by 2026, major infrastructure by 2030, first large-scale human settlement by the early 2030s, growing to thousands of colonists by 2040, and reaching that critical mass of 1 million people by 2050. Can it actually happen? The engineering is sound, the resources exist on Mars, the technology is either ready or rapidly developing. The biggest unknown isn't whether we can do it technically, it's whether we have the collective will and resources to actually commit to a project this massive. But if we do, if SpaceX really does build that city on Mars, it won't just be the greatest engineering achievement in human history. It'll be the moment our species stopped being fragile. The moment we ensured that no single catastrophe, no matter how devastating, could wipe out human civilization completely. A city on Mars means humanity has a backup, a second home, a foothold in the cosmos that makes us genuinely multiplanetary. And from that foothold, who knows how far we might go.